Hello, this is Matthew Caffrey, and I'll be going over systems of equations today, specifically within the SAT context. But I'm going to go beyond that a little bit just to deepen your understanding on the topic. What I've said in the past is that systems, when you have systems of equations, that's a very common way to differentiate between A's and B's on college exams. So regardless of whether it comes up a lot in the SAT, I think it does come up a fair amount. Just statistically, but beyond that, this is a really important concept for everybody to understand if you're college bound, especially if you're interested in STEM. So that's going to be the main purpose of this video, is going over some SAT specific context problems, but then going beyond that a little bit. So let me go ahead and get started. The first thing I'm going to do, I'm going to share my screen here. And I'm going to start actually just looking at our call and response. So for our call and response, we are under the big bucket systems. We're going to talk about both concepts within that big bucket. One being two equations, two variables. The key thing for problems like this, for two equations, two variables, it's often a word problem. And it's often going to involve finding the equations. So two equations, two variables, you have to find the two equations and the two variables. That's what makes it more difficult. Now, systems of equations under the systems big bucket, it's more just, I would say, straight math. So it's just solving. Sometimes both these concepts are combined when you have to figure out what the equations are and then also solve them. That's how it works in college. Sometimes the SAT you have to do both, but a lot of times you have to do one or the other. And we'll see some examples of that. So what I want to do to start off, I think the expectation for you will be to take some notes as we go along. Once you do take the notes, I'll just want you to take a photo of those notes and send them to me. You already have my number. So to start off, how to do this, I'm going to look at this slide show. So for the big bucket systems, just kind of looking in this, I want to start, well, let's just start with a classic problem. How about you go ahead and pause this video now, like right now it's solved, and use your usual strategies. So go ahead, and this concept is system of equations. Here you're just doing the math. So go ahead and solve now, pause. And now you're back after you've solved it, hopefully gotten an answer. I'm going to go and work the problem now, just in case you weren't sure. You feel free to fast forward if this is redundant. What I would do for here, there's two different ways to do it. You could either cancel X or Y. Now, if it's looking for the value of X, it's going to be easier if you cancel the Y. So to do that, I'm going to go ahead and multiply this one. We want it to be a negative 2y, so I'm going to multiply this just by 2. And then we're going to get 2 times 0.5. Hopefully that's something you can do in your head. I'm not sure if this would be a calculator question or not, but 2 times 0.15 will just be 1. So this basically just gives you 1x, which is just x. Write that there, minus 2y. And I apologize for my mouse handwriting. I'm a little bit out of practice. X minus 2y, and then 2 times 10 is 20. So normally I would just write this directly above it. I'm going to save time a little bit. But when we combine these two equations, add these two equations, I'm going to write my answer down here. X plus x is 2x. And then 16 plus 20 is 36. From here, we can likely select our answer of C. So that was systems. That was just straight math. I think you're in pretty good shape with the straight math ones. What I really want to push towards is being able to figure out what the equations are and be able to solve them once you do figure them out. Let's clear this. Here we have a similar situation where it's just straight math. Feel free to pause the video now and try and solve this one. I'll solve it too, just so you can see it, just in case you do make a mistake on this or you have any tough time. But it might just go ahead and solve it, go through it. I don't want to spend too much time reviewing on it though. So I'm going to pause. You can pause the video now. Go and hit pause, and then go ahead and solve. Now the big thing, let's just say you've restarted the video, you've worked the whole problem. What I want to point to now is this time it's asking for x plus y, which is kind of weird. That means we have to figure out what both of these pieces are, which is a little bit inconvenient, but not too bad. Personally, when I look at these two equations, we could solve for either one, because we need both. I would just solve for the one that's easier to solve for. So to me, it looks like it's going to be a little bit easier to cancel out the y's by multiplying this by 2. So 2 times 2x is 4x minus 2y equals 16. Okay. Now we're going to combine that with this equation here. Now, normally I would I'll go and copy it down. It's not that hard. X, I don't want to get lazy. X plus 2y equals 4. I'm just copying down the other equation. Now let's go ahead and combine it. We get 5x equals 20. And then we divide both sides by 5. And at this point, you may be tempted to figure out that x is 4. And then you may want to just select this, but that is not right. Don't do that. It's not this, because we have to figure out what x plus y is. I should have written this here. There it says eyes on the prize. So this is the eyes on the prize thing. So we got to figure out what y is as well. So I'm going to substitute 4 into this. Oh, that's weird. Okay, in this case, I guess it doesn't matter, because if you plug in a 4 here, and again, I always substitute into the easier one, so I'm going to substitute into this equation. We will get 4 plus 2y equals 4. Now, when I look at this equation, I immediately know what y is. See if you can figure out what y would be just from looking at it. But then let's go ahead and solve. I'll do that now. We subtract 4 from both sides. From there, 4 minus 4 is 0. 2y is equal to 0. This must mean y is 0. So yeah, that was interesting. So y, because y is 0, x plus y is the same thing as x. And the answer actually is B. Now this would have mattered, I suppose, if we had solved for y first. But yeah, very interesting problem. I'm surprised they did it that way. Either way, if we know the math, we'll be in good shape either way. So let me clear this. So these are more straight math. Let's get into ones that are 2 equations, 2 variables. Now, when I look at a problem like this, I immediately realize it's 2 equations, 2 variables, because they're asking for the equations. I look at these answer choices, and you'd immediately know. I'm not reading this whole thing and to figure out what the concept is. We already know the concept just by looking at the answer choices. Now we do have to read the problem to figure out which one of these is correct, but we may as well look at a little bit of patterns here. So W plus T equals 18, W plus T equals 36. W plus T equals 18, W plus T equals 18, okay. And there's 36's. All right. In a soccer league, each team received 3 points for a win, 1 point for a tie, and 0 points for a loss. The blue jersey team has no losses and a total of 36 points after playing 18 games. Okay. Okay, so a win is worth 3, a tie is worth 1, and a loss is worth 0. When I look in here, I don't see any variables for a loss. Why might that be? Probably has something to do with the fact that 0 is the point value associated with that. So anything times 0 is just going to be 0. So it's going to focus on you only get points from tying and winning, basically. So let's forget it. We don't even care about the losses. Although you don't want to lose, it doesn't really contribute because it's 0. Okay, so blue jersey team has no losses and a total of 36 points after playing 18 games. Okay, so they must have won a certain amount of times, and they must have tied a certain amount of times, and they didn't lose. They didn't lose at all. So W plus T. Sorry for the plus T thing. This is a plus. This is a T. Must be 18 because they played 18 total games. We probably could have guessed that based on the fact that 3 of the equations had W plus T equals 18 in there, but I can go ahead and chop B. Now this 36 points, this is the total amount of points we got. So we know that there are 3 points per win, 1 point per tie. I could put a 1T here, I could just put a T. And this must have given them 36 points. So from this, I can look at our answer choices. This doesn't make sense because a tie isn't worth 3 points. Same with this one. So from there, 3 with W plus T equals 36. And we already eliminated B. So it would have to be A. So this is kind of like a classic 2 equations, 2 variables. We don't actually have to solve the system. That's why this one is not a system of equations concept, but it is a systems big bucket nonetheless. I'm going to clear this and let's keep moving. We got one more problem on this slideshow. Then I'm going to show you some more advanced problems just to deepen your understanding. Because the more comfortable you are with system of equations, the better off you'll be when you go into college and you're taking math and science courses. System of equations comes up a lot in chemistry and physics. Those are the subjects I took, but if you're going into, I would say, heavier math than I even did, I majored in human biology, you'll need to be very good at system of equations. Okay, we'll read this. This must be a grid-in. How many more dresses than shirts did the buyer purchase? So I already know that we have 2 variables. We have dresses and we have shirts. And we're asking for how many more dresses than shirts did it purchase. So we're basically asking for D minus S, although we could figure that out later. But I kind of, unless I make a mistake, I'm pretty sure that's what we're looking for. So let's go ahead and actually come up with our equations. A fashion buyer for a large retail store purchased 315 items for a total of $6,000. Dresses were $25 each, and the shirts were $10 each. This is a classic problem where things are worth certain amounts. You have 2 things, you're trying to figure out how much of each thing you bought. In this case, usually there's one of them that's just the 2 variables added together equals a number. How many dresses were there? How many shirts were there? D plus S. They sold how many items? 315. And somehow it costs $6,000. So the next equation, we're going to use the dollars. This is where on the big bucket, I'm going to leave these annotations here just because I don't want to clear them. But when you look at your big bucket, it's saying 1-step chop. This is true, but also 1 unit per equation. So the units here are, items, how many dresses, how many shirts, and then 315 items. And then the next unit is going to be $6,000, $25, $10. All these three things, because they're the same unit, are going to be in the same equation. 6,000, 25, and 10. So that means they're going to put the 6,000 here. Now just make sure you associate these numbers with the correct one. $25 is the amount of dress, is the price of the dress. So 25D plus 10S. Okay, great. So because this is a problem 36, ask yourself, must this be a grid in or a, well, no, we know it's a grid in. Is it going to be on the calculator section or no calculator section? Think about that for a second. And then you should think like, okay, 36, that's too high to be on the no calculator section because there are only 20 of those. This is a grid in or a calculator section. So you can use a calculator to solve this. That's likely going to be the easiest way to do this. I don't have a calculator on me, but I might just. Well, we can solve for S pretty easily. We can cancel out the S. Let's multiply the top. To cancel the S, I need to multiply the top by -10. So I'm going to do that. I'm going to put it down here. -10D. Oh, go ahead and do this math on your own first. Then watch me do the math. -10D. You can restart now. -10D. Sorry, minus 10S. And be careful here. -10 times 315 is -3,150. All right, let's do this math. Here it cancels. 25 minus 10, that is 15D equals, good grief, 6,000 minus 3,150, 2,800. Oh gosh. Am I getting ahead of myself? 2,850. If you have a calculator, you can check my math if you want to. I'm going to assume I did that right, but I might not have. Oh gosh, what does this mean? I'm going to ignore that for now. It went away. All right, great. So now we got to divide by 15. That's not particularly easy here. But it's still possible. Let's break out our long division. Let's see how good we are at long division. And if you feel like this is a waste of time, you can put it in your calculator. But long division is an important skill nonetheless that I think you're very good at figuring out. Okay, how many times? And this one I want to do this. You could divide by 5 first. Then divide by 3, but let's just divide by 15. Okay. 15 goes into 28. How many times? 1 time. 1 times 15. Subtract. 28 minus 15, what is that? That is, okay, 3, 13. Okay. 15 goes into 13. How many times? I'm pretty sure it's 0 times. 0 times 15 is 0. I hope I didn't make a mistake here. Let's bring down my. No, I wasn't supposed to do it that way. All right, I'm challenging myself here. Well, let's bring down this 5. Oh. 10. 15. How many times is 15 going to 135? Oh my gosh. Well, 15 goes to 150 10 times. Oh my goodness. I think 14 times. Yeah. 14 times. I don't think this is supposed to be a 0. I think this is supposed to be a 14. Because 14 times 15. No, no, no. I'm abandoning ship. I'm sorry. This is my mistake. This is a calculator question. Just put it in your calculator. Yeah. I'm stubborn, so I'm going to still do it by hand, but I don't recommend this route. Divide by 5. This is something I can do. Please skip this. All right, no, I shouldn't have done that. 7, 35, 0. Okay. Apparently it's 570. And I still got to divide that by 3. I don't think that's 114. So we'll see here. I'm gonna put up my calculator. This is crazy. Maybe I made some other mistake along the way. But let's go ahead and put it in that calculator. I'm gonna put in my calculator. I'm gonna put 2850 divided by 15. We gave it the college try. It was 190. So 190 dresses. We still need to find the number of shirts. Which equation do we put it into? This is D. D equals 190. Don't bubble in 190 because it's asking for how many more dresses than shirts. We still got to find the shirts. I recommend plugging into this equation. So that's 190 plus S equals 315. Do 315 minus 190 to get the number of shirts. 315 minus 190. Yeah, I'm embracing the calculator now. After that embarrassment. 125. Okay, so remember, we're looking for the number, how many more dresses are than shirts. So your last step is going to be this subtraction problem, which I am going to do, not using my calculator for this one. I'm doing it old school. We're going to borrow. Make this a 10. 5, 6. I believe your answer is 65. You can check my math if you have any questions, but I think the main thing is, and don't even worry about that. Main thing is get to here, use your calculator for the last step. Or you could have used your calculator earlier than that. This is a 36 question, so this is a pretty tough problem. So it doesn't get much harder than this, just as far as systems go. I want to go over a few other types of problems though with you at the time that we have. So I'm going to work till approximately 6, unless I finish up early. So this is SAT specific. Let's now go a little bit beyond that. And you can think of this as preparation for your chemistry class when you go to college. You gotta find it first. So I'm going to pause this for 1 second. All right, so we're back. I'm going to share my screen, and I've got some some practice problems here that I wrote a while ago for one of my students I was working with. Okay, so let's just say, Matthew, I guess that's me. I walk into a convenience store and I buy 3 candy bars and 4 slices of pizza for $18. And then later, Max buys 8 slices of pizza and 2 candy bars for $28. And I want you to tell me, how much does 1 candy bar cost at the convenience store? How much does a slice of pizza cost at the candy store? Go ahead and work this on your own. Pause the video and then restart it to see my explanation. So you may pause now. Okay, so if you've hit play, that's good. You can kind of fast forward to the answer if you'd like to, but I'm going to go ahead and work through the problem. This is like a really very common type of problem where you have, 2 different prices, $18, $28, and 2 people they buy some amount of the same thing, but different amounts. So oftentimes, the way this is structured, Matthew walks into a convenience store and buys 3 candy bars and 4 slices of pizza for $18. Oftentimes, a full sentence is one equation. So we'll make this our first equation. Then our next equation is right here. Later that day, Max buys 8 slices of pizza and 2 candy bars for $28. This is going to be our second equation. So keep in mind, this is an SAT question. They may have, maybe you don't have to solve it. You just have to come up with the equations. You can use your strategies to actually answer them. We're going to do a little bit of both. We're going to use both the concepts under system equations. So for now, let's just figure out what the equations actually are. So first, let's do the Matthew equation. 3 candy bars. Let's do 3C, 4 slices of pizza. 4P is equal to $18. There's one equation. Now the next equation. See, they reverse the order. You got to be careful. It's not 8C, it's 2C. And then 8P is equal to 28. Okay, so in this case, I'm asking for both, it seems. Which variable is easier to cancel? Assuming we're going to do elimination. You always can do substitution, but I think elimination is going to be our best bet. It's going to be easier, I think, to cancel the P by multiplying this top equation by what? By -2. So I do that, I'm just going to rewrite this thing right down here. -2 times 3C, that's -6C. And you can pause it if you like, or just looking for this hint, and then restart, work at your own pace. -2 times 4P is -8P. -2 times 18, that's -36. This is going to be kind of a headache because we're going to get some negative numbers in here, but don't stress. -4C. Know that if it's a grid problem, your answer is not going to be negative. But that doesn't mean that you won't have to deal with negatives in the solving process. 28 minus 36. What is that? -8. Divide both sides by -4. You will get the candy to cost $2. That's fairly realistic. All right, so the candy costs $2. Let's solve for the pizza now. Which equation is easier to plug into? They're about the same. Let's plug into the top one. 6, 3 times 2 is 6, plus 4P equals 18. This is the equation we have to solve. Go ahead and solve it. Subtract 6, divide by 4. I believe you'll get $3 for a slice of pizza. That's a little expensive for a convenience store pizza, but I think that makes sense. And if you ever want to check your answers, you can plug it into one of the equations. So like 3 times 2 plus 4 times 3, does that give you 18? Yes, it does. We can check our work and make sure that it's correct. So that's our first example. Let's try out another one. Now this one's really interesting. I want you to pause and I want you to think about what equations you would use for this. So take some time and think about it, but then I'll review it. And this is very, very similar to chemistry problems where you're solving for isotopes, figuring out how much of one isotope of chlorine there is versus another isotope of chlorine. But go ahead and go through it and pause. Okay, if you're back, we'll go ahead and solve this problem now. This is a really interesting type. So let's go through it. An alien species discovered on Jupiter's moon, Europa. This species has 2 sexes, just like animals on Earth, male and female. All males are 5 feet tall, and all women are 6 feet tall. So there's no height variation. Very strange aliens here. The average height of the species is 5.338. How could the average of the species be less than 5.5? Well, it must mean that there are which one's going to have more? The males or the females? If the average height is closer to 5 than 6, what do you think? If it's closer to 5, there must be more men on this moon of Jupiter. So let's go ahead and break this down a little bit more. It's asking for what percent of the alien species is female. Then it asks, what is the male to female ratio? Gender ratios is a very common topic, a little bit more of a social sciences thing, but it's important to understand it nonetheless. So let's go into this. I'm looking at this and I'm trying to think of, what our 2 equations would be. And whenever you have an equation where it asks for a percent, what percent? The percent of females and the percent of males, if you add those percents together, how much percent would you get? And the answer to that has to be 100%. So we're going to use that equation as our first bit. So I'm going to define 2 things. I'm going to define M as the percent males. I'm going to define F, I apologize for my mouse handwriting, as the percent females. Now, hopefully you understand that these 2 percents have to add up to 100%. However, you could do it with percents, but I'm actually going to do it as decimals. So this is going to be some decimal. Those things are going to be just decimals that add up to 100%, which is the same thing as 1. So I'm going to say M. Oh, wow. Hold on. Let me undo that. M plus F has to equal 1. You'll see why I did that. Why I did 1 instead of 100 in a bit. But yet, somehow, now let's look at this equation. All males are 5 feet tall. All women are 6 feet tall. And the average is this feet tall. Now the next equation, let's see if this makes sense. 5 feet tall men, their percent, plus 6 feet tall women. And I'm using men and women. I guess I should be using males and females, but whatever. 5M and 6F, just because if it's an alien, is it really a man or a woman? It's male and female is better. So 5 males, 6 females has to give you an average height of 5.338. So at this point, I'm going to say this is definitely a calculator question. I still think I want to use elimination here. So I'm going to try, and it's going to work out really well. I'm going to try and cancel out the M's because we're asking for the female ratio. So let's cancel out M. Let's multiply And take a second to review, I guess, the equations and make sure they make sense to you. I know I'm not here to answer your questions immediately, but the percent males plus the percent females have to add up to 100%. And then whatever percent males there are is 5 feet, whatever percent females are 6 feet. Somehow that has to combine to give you an average height of 5.338. Anyway, let's multiply this top one. If we're going to cancel the m's, I want to multiply by -5. Okay. And as always, I'm going to stick this right here. Minus 5m minus 6f. Wait, no. I wanted to do that. Doesn't make sense though. Minus 5f. Sorry about that. What's -5 times 1? Interesting enough, it's -5. Now we're going to combine these equations. This cancels. What's 6f minus 5f? Conveniently, it is 1f. And then f is going to be 5.338 minus 5. That is just 0.338. And together, 0.338. What percent is that? If it asks for a percent, maybe you want to convert it from a decimal to percent. But I'm going to write our answer here as 0.338, or depending on how the question's said, I would personally accept that answer, either one, or it would be 33.8%. Very interesting. So this is the system equation. This is how isotopes work in chemistry. You know, the atomic mass of chlorine, I think it's like 35 point, I don't remember, 45, something like that. That means there's more of one isotope than another. And together, the average isotope mass is this. So this is really common. Now, what is the male to female ratio? To figure that out, we need to know what the male percent is. If the female percent was 33.8%, the male percent must be, 1 minus 0.338. Let's go ahead and put that in our calculator. I'm feeling lazy. 1 minus 0.338. What would that give you? Would that give you I'm using my calculator today. I've already proved. It's been a long day. Yeah, it's 0.5 something. 0.33, oh, whoops. 0.338. Well, 1 minus 0.338. Oh, it's 0.6, never mind. 0.662. So the male ratio, so no, not the male ratio, the male percent is 0.662. Well, that's the decimal, 0.662, or you can think of it as 66.2%. Now, the male to female ratio is when you take the male decimal and divided by the female decimal, or the male percent divided by the female percent. I'm going to use the decimals because I'm just habitually used to that. It'll be the same either way. 0.662 all over 0.338. I look at this and I think it's going to be about 2, but it won't be exactly that. It's going to be 0.662 divided by 0.338 is 1.95. This is our ratio. This is our answer. So understanding gender ratios is just often it's a social science data thing, but technically for every 1.95 males there will be 1 female. This is basically how many times more males there are than females. It's 1.95. That was an interesting problem. I think just be familiar with this idea, and eventually you're going to have to do this in chemistry, if you haven't already been doing this in chemistry. All right, anything else we want to do? I'm feeling pretty good about this. Yeah. these are some other problems. If you wanted to, you really don't need to do this. I think that's sufficient at this point for for the class, and then beyond that, if you are very interested, you could do this problem, pause it, and try and figure this one out. Do it on your own. You can send me your work, and then this one as well. And then there's one last problem that is a 3 variables, I think 3 equations, if I'm understanding it correctly. And this is something that is more of a pre-calc concept. If you've taken pre-calc, you're welcome to try this one. Yeah, but technically for all of these, it's 2 equations, 2 variables. If there were 3 variables, you need 3 equations to solve it. It's very interesting. So I'm going to leave it there, and just take a photo of the work you've done and just send it to the phone number that you have for me, my Google Voice number, which is what is it? 410-343-9802. Just send it to that. So thank you, and I'll see you on Monday for the last day of class before you take your SAT, unless I have your schedule misunderstood. But thank you, and just send me that work once you have it completed.